Okay, they're going to make 3 more attempts to break us with alkenes. Let's see how it goes. Okay, so we have to include this double bond in our primary, so that's in there for sure, but we could then go this way, which is 2 carbons, or this way, which is 2 carbons. It really shouldn't matter. I'm going to take the slightly oddball version just for fun. And from here, we could go 1 carbon down or 3 carbons left. Clearly, we must take the longest path. So there is our primary. What is that? It's got 1, 2, 3, 4, 5, 6, 7 carbons in it, so it would be a heptane if it were all single bonds. This makes it a heptene. Heptene. And that double is either on carbon 3 if you count from this end, or carbon 4 if you count from this end. So apparently we're counting from this end, and that's carbon number 1. This is hept3ene. For branches, we have a methyl group, which starts with M, and an ethyl group, which starts with E. E goes first. So first, second, third carbon has an ethyl group on it, so we say 3-ethyl. And the fourth carbon has the methyl group on it, so 4-methyl. Can I fit that in? Just barely. 3-ethyl, 4-methyl, hep3ene. Nice minimalist thing. What's 2 carbons? Ethane, or with a double bond, ethene. Guess what? The name's just ethene. Do you see why? When you have 2 carbons, there's only one place the double bond can be, and it's between those 2 carbons, so the only number you could possibly put here is F1ene. Because that's obvious and redundant, they just leave it out and say ethene. If you put F1ene, you're not wrong, but you're probably going to get some red ink saying redundant or don't need this, so just leave it out. Anytime the number is missing, there should be a good reason for it. And finally, what does this thing have? We have to include this double bond in our primary. These are symmetric, so we can go 2 carbons this way or this way. It doesn't matter much. I'll take this one. And that's in the primary. And here we could go up or down. It's 2 carbons either way, so I'll do this. That's not the nicest primary you could possibly pick, but it's still going to work. So how many carbons are we talking about? 1, 2, 3, 4, 5, 6. This is a hexene. Hexene. Where is the double? 1, 2. It's on carbon number 3, or because this thing's symmetric, not surprisingly, you get 3 either way. So it's hex3ene. That takes care of the primary. And then we have an ethyl group here and another ethyl group over here. When you have 2 ethyl groups, you call it a diethyl. Don't forget the di, it's important. And where are those ethyl groups? We still haven't committed to whether we're numbering from the left or the right, but since one of these is on carbon number 3 and the other is on carbon number 4, that's going to be true whichever end we number it from. So number it from whichever end you want. Either way, you will get 3 and 4. So 3, 4, diethyl, X3ene. I know it feels a little redundant to say di when you've just said they're on carbons 3 and 4, but the people who wrote the book said you need to have this in here, so you need to have it in there. Sorry about that.